So this is basically a continuation of 1-3. And 1-3 is just, what is it? More on functions. More junk on more functions. So the first picture kind of looks like this. And I just wanted to go over it really quickly. What's the domain? I know, but what's the domain of that picture? Negative infinity to positive infinity. What's the range?
Well, we said negative infinity to positive 5.
Negative infinity to positive. Ooh, negative infinity to positive 5. Bracket. All right. While we're looking at it, what's a good one? What's f of negative 1?
It's 3.
How'd you find it? When
When
you write f of negative 1, what's the negative 1 represent?
X.
So this is x equals negative 1.
So it hits the line.
Go here and go straight up. And you go up how far?
Till negative. So it hits the line.
Yeah, until you get to 3.
Yeah.
Let's see, is there another one? What is, approximately, I'm not going to be precise, when does f of x equal 2? What does that mean?
About 0.5 or 0.5, sorry. It's where that 2 is y and the x is y.
So y is equal to 2. Now, 0.5 is one of the answers, but people always forget the second one. If this is y equals 2, it goes this way and hits the graph here, which is about 0.5, but it also hits it
at 5.5.
over here, negative.
Negative 5. Negative.
No, it hits it
It hits it at negative 5.5 because yours is different.
No, I'm looking at mine.
Negative 5.5.
Oh, I know. My picture up here is, but you're going to hit it twice.
Yeah.
One of them is at negative 0.5, and the other one is at about negative 5.5. Yeah, my picture up here is just approximate. I just want you to go by the perfect graph, which is much better than my picture. All right, so these are some of the ideas you should know how to do right off the top of the bat. This one, for some reason, people only see one answer. Be really careful. If you see f of x equals a number, just draw a horizontal line. And wherever it hits the graph, you have to label each one of those. Besides this, we have to talk about increasing and decreasing. So what does it mean that a graph is increasing? Now, describing it is one thing. Defining it is a little bit harder. So when you talk about an increasing function, I always think of it as stock prices. When you see a stock ticker, which way is good? As you move left to right, it's going uphill. So we think of increasing as generally in that direction. Arrows have no relevance on increasing and decreasing. So basically, when you see an arrow on a graph, ignore it completely and just look at, as you move left to right, are you going uphill or are you going downhill? So when you look at this function, and we take like 2 points on it, call this one A, call this one B, I need to define precisely what it means to be an increasing function. So if this is f of x, what's the coordinate of that point right there? Let's change colors. Well, the x coordinate is A. What's the y coordinate? F of A. We talked about this the other day. This is f of A. Then this point over here is B, comma, f of B. What can you tell me about a relationship, as in greater than, less than, between A and B? All right, if B is bigger than A, what's true about f of B and f of A then?
F of B is going to be greater than
And f of B is also greater than f of A. These two conditions define what it means to be an increasing function. If B is bigger than A, then f of B also must be bigger than f of A. All right, take a guess what it means to be decreasing. If B is bigger than A, what must be true about their function?
FA must be greater than f of B.
Well, you could do it that way, or f of B is less than f of A. This would define a decreasing function. So even if you didn't have a picture, you should be able to determine a little bit if the function is generally increasing or generally decreasing. Pick 2 points, figure out what their y values are.
So the x value doesn't really matter all that much?
Well, as long as you keep the order big, the second coordinate is bigger than the first coordinate, then it's increasing if it's greater than and it's decreasing if it's less than.
Okay.
As long as you go second to first.
It doesn't matter if both of them are less than or.
Well, if you flip these to both less
Yeah.
than,
Yeah, never mind.
then it's still increasing. So if they alternate, it's decreasing. If they're the same, increasing.
Hey.
Hey. Hey.
The increasing and decreasing, the B is bigger than A on both of them. I got
What
lost
do
right
you
there.
If B is bigger than A in this case, f of B turned out to be bigger than f of A. If you have a decreasing function, it would be going this way, right? Here's A, here's B. Plot your points. This is f of B.
Okay, it's on there.
It's smaller than f of A. I know, it's a weird way of looking at it. All right, so if we go back to this first picture, and I say, oh, I don't want to use that one. When is this graph increasing and when is it decreasing? So let's look at increasing first. When is this graph increasing? Now, do you care about the y values? No, you have to label this according to all possible graphs, and we're worried about moving left to right, so that's only x values we're talking about. So for what x values is this thing increasing, going uphill?
-3 to 5.
I love when people say 5.
To -3.
To -3. If you're moving left to right, the only numbers you can look at are the x-axis. So this thing is increasing all the way up to this point up here, which is called what? Well, it's called the vertex of a parabola, but it's also a maximum. And in this case, it's a absolute maximum. So this thing is increasing -infinity all the way up to -3. Now, depending on what textbook you read, some textbooks will put a parentheses, some will put a bracket. In this case, it really doesn't matter because at -3, this thing is neither increasing nor is it decreasing. It's actually at a standstill. But I'm going to put a parentheses. That was my habit. So for increasing and decreasing, whether you have parentheses or brackets is a little bit looser, but with domain and range, you have to be very specific about brackets and parentheses. All right, when is this graph decreasing? -3 to +infinity. The other side of the graph is coming downhill. And it starts at -3 and it goes downhill until it goes to infinity. Easy? Try graph number 2 then. Graph number 2 looks like this. I'm just drawing a possibility. Let's see, it's a solid circle here, goes off that way. Open circle here, goes down that way. Coordinate of this point, that's not there.
-2, -1.
-2, -1. Coordinate of this point,
3, and 2.5.
2.5.
Or so.
Was that weird?
Yeah.
I am that weird, but usually I'm trying to stay on integers. All right, so what's the domain of this thing? -infinity to -2. Now, is it -infinity because this is going down?
No.
Guys,
No,
left.
because it's
Left.
going that one left.
That's going to the left. All right. Parentheses or bracket?
Bracket.
Parentheses.
Parentheses. Why?
Right there.
Because it's not
It's an open circle. It's not there. Union. Where do we start up again?
3.
3. Off to
Positive.
positive infinity. So that would be the domain of this entire function. All right. Range. How far down does it go? Negative infinity. Up until?
-1. -1.
I want to make sure people are corresponding. When we're moving up and down, what value should you be looking at? Just the y coordinate. So it should stop at -1. Union. Where does it start again?
It starts back up at 2.5.
Please don't say 3.
Sorry, I started
2.5. It goes off to infinity. When is this graph increasing?
it's increased. 3 from 2.5 to infinity.
No.
No,
From
because
Negative
it's from
infinity.
it's still increasing when it's the first one is still
Negative infinity
increasing.
from 1.
This one is increasing,
Yeah.
and this one is increasing.
Yes.
Union.
All domain. You want to be lazy? You write that. It is over the entire domain that this thing is increasing. Or you copy down exactly what the domain is.
That's right.
Because it's increasing for the entire domain.
Which is be lazy.
Be lazy.
Yeah.
Be lazy.
Yeah.
Decreasing.
None.
Does not exist. There's another one that the book talks about, and it's called constant. Very rarely do you run into a function that's increasing, constant, decreasing. Because that doesn't exist in the real world.
What does it look like then?
What would it look like?
Yeah.
You know, you'd have an increasing, constant, decreasing. And the problem with it is, if this is a real world type of situation, like this is your motion, all of a sudden you're traveling north and then instantly you're traveling east. You know what that would do to your body?
It would hurt.
You'd probably split apart into a couple pieces. Instantaneous change in direction is impossible. So you don't see too many graphs that actually do it. All right, so we're pretty good with increasing and decreasing? You think? Maybe.
I have a small question about what would you do, how would you define that one, the instantaneous?
You don't define it. You just say this thing's increasing up to this point. It's constant from here to here. It's decreasing to that. You can't really define it. It would be a piecewise function. All right. How about? Should I even bother with the next two?
Yeah.
Yeah.
I think we should try it. It's gonna be fun. It looks like
This one. You're going to see this graph eventually, so you might as well get used to it. Starts down here someplace, comes up, goes down, comes up. I'm going to draw it horribly, and it has an open circle there, and a closed circle there. Sine or cosine graph, one of the two. Okay, this crossing is actually here, so it's the same height as the other one, and these are the same depth all the way across. What's the coordinate of this point?
-6, -5.
-6, -5. This coordinate here?
-6, -2, -5.
-2, -5? This coordinate here?
0, 5.
2,
Oh, that one.
-5.
Down in the bottom.
Oh,
Okay. We'll stick with those, and then we'll get the high ones. This one?
-5, 3.
-5, 3.
-3.
And this one is?
It's -4, 3. -4.
Which one?
That one. -4.
-4, 3. And this one, of course, is?
0,
3. And the open circle?
Is 3, -1.
3, -1. All right, domain.
-6, 3.
-6
to 3.
to 3.
That's a bracket.
Bracket
And then parentheses.
and a parentheses. Range.
-5 to 3.
-5 to 3.
And then it's both brackets.
And it's both brackets. Starts down here at -5 and it works its way up to 3. Even though it repeats the 3 over and over again, we don't care about that.
Why do you have a parentheses around the 3?
This one?
Yeah.
Because when you get to this end point, the domain here is 3, right? It's not there. And once it's not there, it's parentheses. I'm not talking about up there.
Yeah, I just got
Left or right, left or right. And then the range is down to up. So how far down does it go? -5. How far up does it go? 3. All right, increasing. This gets even worse. When is this graph increasing? Only for domain values. From negative all the way to -4. So this would be -6 to -4. Brackets or parentheses, I could care less. Union. Where else is it increasing?
-2 to 0.
-2 from this point all the way up to this point, which has a domain of 0. So -2 to 0. Where else is it increasing?
2 to 3.
2 to 3. But here you definitely need, that one has to be a parentheses. When's it decreasing? Well, all the places where it isn't increasing.
Yeah.
Pretty much. So what are they?
-4
-4 to
-2.
-2.
0 to
-4 to -2. 0 to 2. And then? That's it.
Yeah.
What is this point called?
Relative.
Is it an absolute minimum or a relative minimum?
Relative.
Now that one's up to debate because
There's other ones, there's 2 more.
it's an absolute,
Because
but it repeats over and over again. So pretty much you kind of wing it and just call it minimum.
Yeah.
Don't even give it a first name, just call it a minimum. And these up here are maximums or repeated
I
maximums.
thought you said use the Y when you decrease.
When you're increasing and decreasing, you always are going left to right, so you only care about x values. The only one that cares about a y value is right here. Don't look at y values other than range. Everything else is x values.
But like on the other one, you use the increasing from -10 to be -3 and -3.
This one?
No, not that one.
Did I erase it already?
Yeah, the first one.
Yeah, the first one.
Oh, my,
You use
yeah.
Y.
I did?
Yes.
How dare I?
No, you
There's
didn't.
no way I did.
No, it didn't. The decreasing is -3.
The increase, the increasing is negative infinity to -3.
And then he did -3 to
-3 to positive infinity.
He used the X.
Mm-mm.
-3 is the X.
-3 on the x-axis. Go up and you'll find the vertex. Plot a point, get a coordinate. Trust me, on the test, plot these points, write the coordinates so you can keep straight which one's x and which one is y. Those are the most confusing ones. Oh, the quiz today, I mix them all up.
Oh, yeah.
Just to screw up your mind.
Well, what dyslexia is about that?
Yeah, to get rid of your dyslexia. All right, how about, I'll let you do number 4 on your own if you want. There's other pieces in here that I could care less about. Piece number 1 I could care less about. I'll teach it, but I don't really use it that often. This comes in handy if you're in polar coordinate land. And also if you take differential equations. Yeah. If you become an engineer, this becomes really important because it cuts your work in half, if not into a quarter. If you have an even function, it's defined to be this. If you evaluate f of -x, you get back your original function. I'll give you examples of these in a second. An odd function is if you evaluate f of -x and you come back with opposite of the original function.
Wait, you did the opposite the first one.
This is f of -x equals f of x. This is f of -x equals negative f of x. So one brings you back to your original function, the other one brings you back to its complete opposite. So if an even function, a good example of one, f of x equals x to the 4th plus x squared. I can put the coefficients in here and all that fun stuff, but it really doesn't matter. Yeah, leave it alone. To determine if this is an even or odd function, you just evaluate it for -x. Replace your x's with parentheses, so you don't make any silly sign mistakes. What goes in the parentheses? -x. And what happens is, when you raise a negative to an even power, what happens?
It becomes positive.
So you get x to the 4th plus x squared, which is your original function. You're back to where you started. All right, if you have an odd function, something that looks like f of x equals 3x cubed minus x. Probably be a good one for an odd. To determine if it is indeed odd, you evaluate this thing at -x. So you go f evaluated at -x is equal to 3 times something cubed minus something. What goes into somethings? -x. So this becomes f of -x is equal to, what happens here? Negative raised to a 3rd keeps it.
Negative.
Might as well put that in front of the 3. -3x cubed. Negative times a negative is a positive x. If I factor out a -1, this becomes -1 times x cubed, 3x cubed minus x, which is the original function, but it's the opposite of it. So this one is considered even, this one is considered odd. If you're dealing with an even graph, it's generally symmetric with the y-axis. Parabolas are a good picture. You know, x squared plus 4 would be a perfectly symmetrical with the y-axis. Odd functions, on the other hand, are symmetrical with the origin. That means if you pick any point on this side and reflect it through the origin, you find a corresponding point on the other side that's right on the graph. So the distance from this point to the origin, take it, double it, you find a point on the other side, and vice versa. So if you look at this point here, you cross through the origin, you end up with this point over here. It's kind of a cool idea, but not really powerful for our purposes. But that's even and odd, just in case you run across it.
Wait, where is the even function symmetrical?
Over the y-axis. So any point that's over here reflects directly over the y-axis and generates another point on the other side. The y-axis is also named axis of symmetry for parabolas. That's even and odd. All right, so that leads us into 1-4. There are two pieces that I have skipped in 1-2 and 1-3. One of them is called the difference quotient, and the other one is called average rate of change. They're probably the two of the harder topics, but I don't like talking about them until I deal with 1-4. What's 1-4's title? 1-4. Slope. Now, I can bring in a textbook in here. It's about this thick. It's called calculus, and half of the book is dealing with that one word. A whole complex math is based on just this idea of slope. Most of you know what slope is, right?
It's like
It's the rise and run thing, yeah. I worry about slope because most teachers just jump into it and say, here's the slope formula, good luck. But they don't describe why it actually works. So I like describing why. If you have two coordinates,